All right, we're in AP Calculus. Today's date is Wednesday, January 8th. 1/8, 2020. We are on lesson 7-3. We're talking about direction today. Who wants to read our objective? No yawn from Gia. We're in a good spot. Who's reading the objective? Arrow. Yes, thank you.
I don't think I've ever done it.
That's why I'm making you do it.
Fine, I'll do it. Determine when an object is at rest, moving in a particular direction, and changing direction.
That's it. If you have those things down both by hand and with a calculator, I realized that my previous objectives is like with and without a calculator. This whole unit is with and without a calculator, so I'm going to stop putting that. And I did do a better job of putting when you need a calculator on the notes right here and in the homework as well, so sorry about that. And if you're watching this video in the future, you're like, those are already corrected. So, velocity. We're going to talk about Mr. Frog. He's going to be hopping along at a constant rate on roller skates, theoretically. And he is moving at 4 feet per second between 0 and t. So you can create an equation, right? So I can say velocity with respect to time is equal to what? 4. Done. Positive 4. This is the same thing as saying, like old school, we've learned this before. It's kind of the same thing as saying f prime of t is equal to 4. Because velocity is the derivative, right? So let's do a little bit of physics review. There are 2 parts, 1 and 2. People from physics, what does a velocity have? Mr. Brown is crying. I hear him over in his room right now. Magnitude and direction. There it is. Okay, thank you. Magnitude. And I guess I should keep this capital direction. Magnitude is the number, right? How big the number is. 2 is bigger than 1, so 2 has a bigger magnitude than 1. And then direction, for at least in AP Calculus, we're keeping it simple. Are you positive or are you negative? That's all I care about. The end. All right, so moving on. Let's talk about Mr. Frog. He's now just having a second journey, which is a little bit harder than just a constant 4 feet per second, say piecewise function. He is going to be starting off not moving. So, okay, Mr. Frog, begin. Okay, he's now starts moving at he's slowly increasing, and now he's moving at something per minute. I'm going to guess inches per minute. I don't know how fast a frog moves. And then now the velocity of Mr. Frog is going down. Now Mr. Frog is going backwards because he's going at a negative velocity. He's going at a negative velocity, and slows down and then stops again. We understand what's happening to Mr. Frog in terms of this graph? We're going to label this graph quite a bit. So let's say right here, what's happening? Quiet raise hand. Gio. That's a direction change. Perfect. What's happening in this giant segment right here, this interval? Which direction is he moving? Let's assume right is the positive direction. Is he moving right or is he moving left? You guys can shout this one out.
Right.
Yeah, so this whole segment right here, you can do kind of a square bracket if you want. I can make it slightly neater. This whole bracket, moving right. Moving right. What about right here at the beginning? What's happening?
It's at rest.
At rest. For this immediate spot, what's happening? I mean, it is a direction change, but if I'm talking about calculus, I can have that infinitesimal point of time. What is another word that I can use that I just wrote down? At rest. It's kind of like whenever you shoot a basketball, that's what I always think of. When you shoot a basketball in terms of its y direction, it kind of hangs in the air, and it's for like an infinitely small period of time that maybe you're in your mind. Michael Jordan is flying through the air to dunk his basketball. It feels like he's almost hanging in air. It's really just an infinitesimal point of time, but he's at rest, kind of like hanging in the air. And then down here, what is this interval? What's happening? Shout it out. Yeah, going left. I'll just say left. And then what's happening over here at 6, 0?
At rest.
At rest again. And he has stopped moving. Okay, so a particle at rest. What is the mathematical definition? And you want to be thinking about this in terms of your f primes. Is it greater than 0, equal to 0, or at 0? So particle at rest is where v of t, well, what is it?
It's at 0.
Equal to 0, perfect. Particle moving right. That's when v of t is positive. Does this feel eerily familiar to something that we've done before? When f prime is greater than 0, that's where f is increasing. Sounds familiar? Okay. Particle moving left, that's where our velocity is, shout it out, less than 0. And particle changes direction, that's where vt or f prime has a
Negative.
sign change. Yeah. So again, if I had Mr. Frog do something like this, where he was moving along and then he came and touched here and then came back here, he didn't change direction. He's still moving in the right direction. He stopped and then moved the same direction. He didn't change direction, so it's not a sign change. You have to go through the axis in order to be a sign change. So velocity, sign change. All right, calculators, pull them out.
We left our calculator in the classroom.
Did you?
Yes.
I have a ton of calculators. I had a classroom of 6 one time.
Here we go.
Doesn't mean I have 6 working calculators, but I have 6 calculators. The 4th one's the charm. God darn. The 5th one is the charm. Mr. Sindel, you need new batteries. Okay.
We should separate the ones that don't work from the ones that do work.
That sounds like a prudent idea.
Can just put on a battery.
Yeah, those ones charge. I have a wire and they just charge. It's way simpler. All right. So, graphing a function. Let's, make up a function. I want to graph y is equal to natural log of something fun. Let's do something interesting. E to the power of x squared. And you might be thinking, I wonder what that's going to be. And you can you picture this, what this is going to look like in your head?
Nope.
Oh, I was hoping one of you would be like, oh yeah, you can use log properties. It's going to be looking like a parabola. And okay, it's okay. We'll see what this looks like by using our calculators. So, on our calculators, the first button that we press is the y equals button. And whenever I do like a square around it, that means it's a button. I'm trying to just help you in your notes. So you hit your y equals button. Let me open up my Wabbit EMU. I'm sure my other one would work. I can give it a shot. Give them both a shot. Wabbit EMU, open, open, file, open recent. You go your y equals button, and then you enter the function. Oh yeah, I updated my calculator from yesterday, so maybe it works. Oh, I have to do everything again though. Because you have to there's no keys. Okay, it's gonna take me a while to set up. I'm not doing that today, I'll do that another day. It takes a while. So y equals, and then you do natural log of second e to the power of x to the power of 2. It looks weird on the TI 83 pluses, but there it is. You guys can enter it obviously on yours and then get it out of that. Okay. Well, you don't actually need to get out of it. So the next step is to enter your function. And then the third step is the one that you haven't done before, is to hit the graph button. And it will be a graph of a parabola. It's like, wait, why did that work?
Because the e cancels the natural log out, and then it's just x squared, right?
Exactly, yeah. So one cool thing that I should be entering in here, I'm pretty sure I kind of messed up the notes a little bit, is the zoom. Or sorry, the window and the zoom. This is super key. Let's all hit window now. Hit the window button. On the window, let's change our x min to -4 4 and our x max to 4. And by the way, the negative button is to the left of the enter sign. It is not above the plus sign. That is a minus. Minus and negative are different on this calculator. So do -4 to 4. Do not worry about your y's, because what we're going to do is we're going to zoom into that x range. Because in AP calculus, they're always going to say, hey, your x window is going to be between here and here. I'll be telling you that on this homework. So like down here, I'm going to say, hey, between 0 and 14, so you'll program your window between 0 and 14. I will tell you your range. The next thing that you're going to do is you're going to hit zoom 0. And 0, by the way, is zoom to fit. Zoom to fit that x interval that you have. So zoom 0, and then you'll get a more interesting graph, a little bit more accurate, because you're kind of zooming into that correct interval. And you might be saying to yourself, Mr. Sindel, that's cool, but isn't Desmos like way easier? You can click and zoom and do a bunch of things, and I can type, and I know that system. And my answer to all of that is yes, I hate the fact that we have to use this stupid calculator, because it is way old. Like the system, everything, the hardware, it is like 10, 15, I don't even know. It's super old, and there's a giant push. Texas is kind of leading the charge right now. Allow Desmos on like a locked tablet and make sure that people can't access the internet. It's a whole conversation that we could have, but unfortunately for this year, we're using this calculator. So we'll have to learn how to use it. I'm a little bit sad about it, but there it is. Everyone sees that. They got the correct window. It looks good. All right, so in your notes, what I want you to say is the second step. I guess you can think of this as the window button, and then correct x intervals. And then you can hit zoom, hit the button zoom, and then hit the button 0. And that's actually a better way of hitting graph. So this graph actually is turning into 2 separate steps where you're doing window, enter your x intervals, and then hit zoom 0. That's how you really want to graph from here on out. I mean, obviously, if you just hit the graph button, that will work, but it's better to hit window, set x intervals, zoom 0. Okay, anyway, let's find some zeros. So I'm going to change my function now. Let's go ahead and just make this thing minus, I don't know, 2. Something to make this a little bit more interesting, because our x-intercept is super easy right now. It's 0. So if I change my function to this -2, I come back over here to hit my y equals, scroll all the way over, -2, and then I can hit zoom 0 again. Again, we don't have to set the x intervals again because it's already been set. And you can say, okay, well, I clearly see that it's intersecting the x-intercept here and here, and I'm going to wait for you guys to probably catch up. But how do we figure out what that exact value is? We'll round it to 3 decimal places, of course. And the answer is there is a way to do that. I mean, some people might think, oh, well, if I just trace that, this is not the way to do it, and I just scroll over, scroll, you can kind of see this thing moving. If I scroll over, I'll get approximately where it is, right about there. There's a more exact way of doing it and a quicker way of doing it. Here you go. Second trace. So in your notes, hit the second button and then hit the trace button. So we're really trying to hit calculate, right? So we're calculating. What are we calculating? We're trying to find a 0 right now, and eventually we're going to be doing these other ones as well. So second trace, and then we're doing 0, so I'm going to hit 2. Second trace 2. Okay, it's saying, okay, find what is your left boundary. So the slow way of doing it, and you can do it either way, the slow way of doing it is hitting left, and then get to the left of the 0, and then hit enter. And then it's asking, what is your right boundary? You can hit right, until right about there, and hit enter. And then where is your guess? Somewhere in between that interval, left a few times, enter, and it'll say, oh, the 0 is right here at -1.414. Oh, that's negative square root of 2, but there it is, -1.414. You can find it. I want to show you the fast way that I would appreciate you to use, because AP test is all about solving it fast, right? So again, let's pretend I didn't have that. I'm going to do second trace 2 to find the zeros. The faster way of doing it is knowing, hey, I can just enter in a number. Let's say my left bound, something crazy, -3. -3 is all the way up there. My right bound, I'm just going to hit 0, enter. And my guess, anywhere in between. It doesn't matter. As long as it's in between, you're good. As long as you got good intervals. I'm going to guess -1. Hit enter. And bada boom, bada bing, we have the same exact answer. So, how do we write that down in our notes? Come back over here. So, I'll say enter number for left bound and number for right bound. And then enter any number in between. Done. That's the process. Enter any number in between. So we're about to give this a shot, making sure we know what's happening. Why do we care about zeros in this lesson? Well, because that's one of the definitions. I'm trying to compare if it's at 0 where it has a sign change. Both change of direction and at rest, I will need to calculate where 0 is. All right, we're ready? Mm-hmm. On to the back. Mr. Sandell is skiing. Starting his time at t equals 0 minutes. His velocity at time t between 0 and 14 is given by the function whose graph is above, and it looks like, I'm going to assume t is in minutes, but I didn't put it up here anywhere. Oh, I did, yeah, t is equal to 0 minutes. So my question for this graph is somewhere between 0 and 14, so somewhere on this graph, where do I go up the mountain? Assume up means positive. Where am I skiing up the mountain? Well, the definition of skiing up the mountain is what? In terms of velocity, it's where velocity is greater than 0. What is velocity on a graph of velocity? Is it height, slope, or concavity? So it's where the height is greater than 0. Well, where is the height greater than 0? Well, I have an interval between here and here and here and here. So between 13 and 14 and between 0 and 8. How do we write that down? We say between 0 and 8, not including 0, 8, union with the other interval 13 to 14. Done. That's a point on the AP. Oh, that's 1 point on the AP test, but we need to justify to get the second point. Sometimes those are combined into 1 point also. So why? And we can say because velocity is greater than 0. Literally what we just wrote over here. So our full answer that you should be writing on the AP test looks like that. We have the answer and the justification all nice and concisely written, nice and short. Let's try another one. B. At what times do I change direction? And also justify. Well, what is the definition of a change of direction? V of t, the velocity is not equal to 0, it's... No, go look at your notes, look at the front side. Sign change. So where do I have a velocity sign change? 8 and 13, perfect. Where does it cross that t-axis? So at t is equal to 8 and 13. Okay, and it asks us to justify. Always assume that you have to justify. I mean, I think I didn't ask it in part B on example 2 because I ran out of space, but always assume it. Time is equal to 18 and 13 because, and we literally write this down again. I'm just going to copy and paste it. I think it's a little bit faster. Because VT sign change. And box it. That's our final answer. All right. That's one without a calculator. Let's try one with a calculator. All right, so now we have this interesting formula for velocity. Let's go ahead and immediately put it in for our y1 for our calculator. So pull up our calculator, go to our y1 function, clear that out, I hit clear, and I enter it. So it's going to be the square root, so I have to do second the x squared button. The square root of, it's going to be our variable x in this case, and then end my parentheses, times, I don't have to hit that, times e to the power of 0.5x. Done. I can end the parentheses, you don't have to, but there it is. That's what it looks like on the TI-83 Plus. The newer calculators, I'm sure, has an easier time of making sure that looks correct. Give me a thumbs up once you have that in your calculator. Thumbs up, thumbs up. Geo, Stego, just waiting on you two. Stego's good. Geo, got it. All right. So now we need to have the correct interval between 0 and 4. That's the only thing that I'm really looking at because that's what it's defined to be in the problem. So I'm going to go to Window, 0, enter, 4, enter. Now I have the correct interval. What's the next step? Shout it out. Zoom, 0. There it is. Let's graph it. And it should look like this. A nice gradual curve. At what times is the particle at rest? Well, since 0 is included in the interval, yeah, 0. At t is equal to 0. Why? Someone aside from Claire. Why is t equal to 0 at the time that it's at rest? Something to do with velocity. You have to have velocity in your answer.
Because velocity is 0.
Boom, there it is. Final answer. I don't even need to box it because all that should be boxed. All right. B. During which time intervals does the particle... Oh, that's a bad question because it's a bad function. Probably should have made a better function. Does it ever move to the left or does it ever move to the right? What's happening here? It's only moving to the right, so this one is not applicable. Why? Because Vt is always greater than 0 for 0 is less than equal to t is less than equal to 4. I will improve that for next year. Make this better, Mr. Sindel. And what time does the particle change direction? Does it ever change direction? It doesn't. Let me see if I made the window slightly different, would that have helped things? I'm pretty sure it still stays above the x-axis. It's a parabola. Oh, there's no domain over here because it's square root of t. Okay. Well, that was a horrible problem. I apologize. Not applicable. Let's move on to the homework.